The last topic of this particular chapter is kurtosis we'll be talking about. So kurtosis, basically it will show you the peakness of the data, how peak the particular data is. So in the skewness you have seen how we do denote the data. Similarly, in kurtosis there are three different ways of denoting the data or the showing the peakness. For example, the first one is which is very flat data where the peakness is there. Then you have the second type where the peakness is little above this, and third type you have where the peakness is very peak. So these are the three representation of peakness we have kurtosis basically. So first one we call it as leptokurtic. This is the median version. Leptokurtic. In this, what happens generally, the beta 2 is equal to 3. So in this, basically beta 2 is equal to 3 and gamma 2 is equal to 0. So this is the condition you have to be the leptokurtic. You know, beta 2 and gamma 3 formula I had given there. Though we don't have a problem based on this, we do have we'll see one or two problems based on that. So this is the condition for the being the leptokurtic. The second one we call it as a mesokurtic. M-E-S-O-kurtic. Now what is the condition for it? The condition for it is beta 2 should be greater than 0 and gamma 2 should be also greater than 0. And the third part, which is very flat, are called as platykurtic. So platykurtic. And the condition is beta 2 should be less than 3 and gamma 2 should also be less than 0. So this is about the kurtosis, basically nothing much to discuss in it, just it will show you the peakness of the data. So these are the three different types of peakness we represent. The first is leptokurtic, mesokurtic and platykurtic, and these are the conditions we have. Right. So now next what are we going to do is we will see one or two problem which is based on the moments and kurtosis, so that you will be able to understand what are we trying to tell about these moments and all. Right. So let's see one question based on this. The first four moments of the distribution is 0, 0, 2.5, 0.7 and 18 point. So first four moment is what? mu1, mu2, mu3 and mu4. So what is mu1? mu1 is 0, 2.5, 0.7, 0, 2.5, 0.7 and 18.75, right, which is given in the question. Test the skewness and kurtosis of the distribution. Test the skewness and kurtosis. So skewness is what? We have two types of skewness. One is beta 1, which is nothing but mu2 square by mu3 square by mu2 cube. So write down the value. mu3 is nothing but 0.7 square by mu2 is nothing but 2.5 cube. Solve this, you will be getting beta 1 as 0.031. 0.031. Similarly, find out beta 2. What does beta 2 say? mu4 by mu2 square. So what is mu4? That is 18.75 divided by mu2 is nothing but 2.5 the whole square. So you will be getting the answer as 3. So you will be getting the answer as 3. So if you see this, what are you getting? Beta 2 is equal to 3, which means it's going on the leptokurtic condition, right? Next, let's find out gamma 1 first. So what is the gamma 1 value? Square root of beta 1. So if you find this, something you will be getting, and similarly you find out gamma 2. So gamma 2 is what? Beta 2 minus 3. So you can see it is 0, which means this curve is nothing but leptokurtic. So this is how we can easily find based on whatever the data they have given, right? So for our standard, we have only very basic problems we have. We are not going into depth about these two topics, right? So this is what about the skewness and kurtosis. I hope you are able to understand this. We'll be uploading a few practice questions very soon. Try practicing as many questions as possible and let us know if you have any doubt with it. With this, we are done with this particular chapter. I'll see you in the next chapter. Thank you.